Is it the screen is visible to all?
Yes, sir.
Yes.
In the last lecture, you see that the definition of characteristic of a ring. Okay, what is the characteristic? If R is a ring with zero element, and suppose there exists a positive integer n such that n into a, okay, with respect to addition, this is the notation, and with respect to multiplication, a raised to n is equal to 0. Okay, such that n into a, which is equal to a plus a up to n times, if it is equal to 0. Okay, and the smallest such a positive integer n is called as characteristic of a ring. Okay, for every element a belongs to R. For example, Z6. Okay, for each and every element belongs to Z6, we have 6 into a is equal to 0 for all a belongs to Z6. Hence, this integer such that 6 into a is equal to 6. We can't get n into a is equal to 0. Okay, so this is the least positive integer. Hence, 6 is the characteristic of a ring Z6. And for any Zn, n is the what? Characteristic of Zn. Okay. Okay. And we also seen that definition of characteristic of a field. Okay, every field is an integral domain, therefore the characteristic of f is 0 or f according to as many as any non-zero element of f is of order 0 or n. Okay, if you have to find the characteristic of the field, find the characteristic of that unity element of that field. Okay, look at here. If the field is finite, then the characteristic of the field also is finite. Okay, look at here. If the order of one is 0, and then left is of characteristic 0. Okay, in the infinite field, every non-zero element has an order 0, and the 0 element has an order 1, which is finite. Okay, any doubt up to here? Yes.
No, sir.
Okay, so the next definition is derivative of a polynomial. Okay, what is the derivative of the polynomial? Definition of derivative of a polynomial. Derivative of a polynomial. Okay, let f of x, let this small f of x is equal to a naught plus a1x plus a2x square plus up to so on an x raised to n. Okay, be a polynomial, over a field f. Okay, capital F. Then the derivative of f of x, the derivative of f of x is f of x denoted by f dash of x and is defined as the polynomial f dash of x is equal to, what is the derivative of this polynomial? a1 plus 2
A1 plus 2a2x up to so on n
into
a
x raised to n minus 1. So this is the derivative of a polynomial. Okay, any doubt up here? Look at this now.
No,
Now
sir.
here, this 2 means, okay, 2 is equal to what? 1 plus 1. Okay, and this n is equal to what? 1 plus 1 plus 1 plus up to n times. Okay, up to n times. Okay, if f is the finite, f is a field of finite characteristic, if the field, which field? This one. If this field is a finite characteristic, P. Okay, suppose the characteristic of that field is P, then the derivative of the polynomial, the derivative the polynomial, okay, x raised to p is, okay, या polynomial का derivative का x raised to p is equal to p into x raised to p minus 1.
0.
Okay, but if the what is the characteristic of that field is p. Okay, so p into any element, x raised to p minus 1, but p is equivalent to what? 0. Okay, so this p into x raised to p minus 1 is equal to 0 into x raised to p minus 1, which is equal to 0. Okay, any doubt? Okay. So,
No, sir.
what is the result of this one? The field is of characteristic p. The field is of characteristic p. Okay, so this implies the characteristic of element 1 element 1 or of the element 1 is p. Okay, so here the p is equivalent to 0. So p into x raised to p minus 1 is equivalent to 0. So thus this implies we see that the derivative of a non-constant polynomial. This is the non-constant polynomial. Which one? X raised to p is the non-constant polynomial. But if the field of characteristic p, okay, if the field has a characteristic is p, then the derivative of a non-constant polynomial is also what? Here 0. Okay, so thus we see that derivative of a non-constant polynomial, a non-constant polynomial can be 0. Okay, if the field f, capital F, okay, is a field of finite characteristic. Okay, any doubt? सांगण्याचा उद्देश काय जर तुमचा फील्ड
No, sir.
No, sir.
कॅरेक्टरिस्टिक फायनाईट असेल पी असेल तर एखाद्या नॉन कॉन्स्टंट पॉलिनॉमियलचाही डेरिव्हेटिव्ह येऊ शकतो. ओके, आता आपण काय बघितलं एवढे दिवस की एखादा पॉलिनॉमियलचा डेरिव्हेटिव्ह 0 कधी येतो जर तो कॉन्स्टंट पॉलिनॉमियल असेल. Okay, suppose f of x is equal to c, then what is f dash of x? 0. Okay, but here the
0.
derivative of a non-constant polynomial is also 0. Why? Because the field is of characteristic p. Okay, for example, in Z7. If f of x is equal to what? X raised to 7. What is the flash of x? 7 into x raised to 6. But 7 is equal to
7x raised
0. Okay, in Z7. This is x raised to 6, so it is equal to 0. So this is f dash of x is equal to 0. Okay. Any doubt here? Okay. So
No,
okay, the next theorem is हा सुद्धा खूप सोपा theorem आहे. Let f capital F be a field, capital F be a field, and let this small f of x, that is the polynomial f of x, is belongs to capital F of x in the polynomial be such that f dash of x is equal to 0. Then prove that. One. Statement number 1. If the characteristic of capital F is equal to 0, then the polynomial f of x is equal to 8. That is constant polynomial which belongs to f. And the second one is, okay, that is the limit. That is f of x is constant polynomial. Okay, when if the characteristic of is 0. If the characteristic of capital F is equal to P, which is prime, okay, not equal to 0, then okay, prime नहीं है बरं का? Characteristic will prime is not okay. If the characteristic of the field if f is prime, which is not equal to 0, then f of x, okay, the nature of f of x will be g of x raised to p. म्हणजे तो पॉलिनॉमियल कशात असेल? x raised to p च्या या फॉर्म मध्ये असेल. Okay, f of x, the nature of f of x is equal to g of x raised to p. Okay, for some polynomial g of x belongs to capital F of x. What is the meaning of this one? That is, f of x is a polynomial in x raised to p. Okay, any doubt in this statement? Read it carefully. Let f be the field and let f of x belongs to capital F of x be such that f dash of x is equal to 0. Okay, त्याचा डेरिव्हेटिव्ह काय येतोय? 0 येतोय. तो कॉन्स्टंट कधी असेल तेव्हा field, the characteristic of the field is 0. If the characteristic of the field is p, then the f of x is the polynomial in x raised to p. That is, f of x is equal to g of x raised to p. Okay. Any doubt in the statement? Hello, आवाज ऐकू येतोय का माझा?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, look at the answer. Let f of x is equal to a naught plus a1x plus a2x square plus up to so an x raised to n. Okay, be a polynomial over the field f capital F. Okay, which means all the coefficients are belongs to capital F. So we have what is given to us? The f dash of x is equal to 0. Okay, so the f dash of x is here a1 plus 2a2x plus 3 a3 x square plus up to so on n into an into x raised to n minus 1. Okay, this is the f dash of x, but it is given that f dash of x is equal to what? 0. That is what? 0 polynomial. Okay, has 0 polynomial elements. Okay, so this implies a1 plus 2a2x plus 3a3x square plus up to so on n into an into x raised to n minus 1, which is equal to what? 0 polynomial. Okay, so this implies by the equality of two polynomials. So we get here a1 is equal to 0, 2a2 is equal to what? 0, 3a3 is equal to 0. Okay. Up to so on. I into ai is equal to 0. Up to so on. N into an is equal to 0. Okay. Here I into ai is the any arbitrary element. Okay. Any doubt up to here? Okay. Now case number 1.
No, sir.
Sir.
This case 1. When the characteristic of the field F is 0. Okay, so we have, okay, take any arbitrary element from this one. So we have I into ai is equal to 0. Okay, what is the meaning of this one? So this implies ai plus up to so on, up to how many times? I times is equal to 0.
I time.
Okay, now look at here. The characteristic of f is 0. Okay, which means every non-zero element has an
0.
order 0 and 0 element has an order 1. Okay, so this implies order of ai regards as an element, as an element of additive group of f is less than or equal to I. Okay, so this implies from this one we can write order of ai is what? Finite. एखाद्या एलिमेंटची ऑर्डर फायनाईट काही असते. इथे कॅरेक्टरिस्टिक ऑफ एफ काय? 0. ओके, नॉन 0 एलिमेंट असेल तर त्याची ऑर्डर काय असते? 0. ओके, आणि 0 एलिमेंट असेल तर त्याची ऑर्डर काय असते? 1. ओके ओके, एनी डाउट? This implies order of ai
No, sir.
as an element of additive group of f which is less than or equal to I. Okay, so the order of ai is what? Finite. So this implies finite order किती असते ते? If and only ai is equal to 0. Okay, because what is the reason? Because in a field of characteristic 0, each non-zero element is of 0 order. Okay, each of zero order, and 0 is the only element. 0 is the only element of finite order. Okay. ह्याच्यावरनं हा स्टेटमेंट कसा आला नीट लक्षात ठेवा. AI plus AI plus AI up to how many times? I times, which is equal to 0. ओके, हा तर 0 होतोय, पण ह्याचा हा लिस्ट पॉझिटिव्ह आहे का हे माहिती नाहीये मला. ओके, ह्याच्या खाली कुठेही होऊ शकतोय 0. Okay, that is order of AI regard as an element of additive group of F is less than or equal to I. Okay, I ला तर 0 होतोय तो, पण I च्या खाली हा लिस्ट आहे का नाही हा मला माहिती नाही. Okay, so this implies what? Order of AI is finite. पण ह्याच्यावरनं काय सांगू शकतोय मी? Order of AI is finite. Okay, आणि finite order कोणाशी असते ते? 0 element, and 0 is the only element of order finite order. Okay, and finite order आहे म्हणजे काय ना मग तो हा AI itself 0 असायला हवा. Okay, because in a field of characteristic 0, each non-zero element is of 0 order, and the 0 element is the only element which has a finite order. Okay, so this implies, but AI is what? Any arbitrary element. So this implies A1 is equal to 0, A2 is equal to 0, up to so on. AI is equal to 0, up to so on. AN is equal to 0. Okay, so this implies what is f of x? A naught plus A1x plus A2x square plus AN x raised to n. Okay, now putting all the values of the coefficient, we get f of x is equal to A naught. But A naught what? This is the constant belongs to the field F. That is, fx is a constant polynomial. Okay, any doubt? Now, case number 2.
No, sir.
When the characteristic of f is p, when the characteristic of field f is equal to p, okay, it's not equal to 0. Okay, look at it. In this case, each non-zero element of the field F is of order. What is the order? P. Okay.
P.
So it is the field characteristic P. So in each case, non-zero element of the field F, that is P, is of order what? P. Okay. And zero element is of order. What is the order?
1.
1. Okay. तुम्हाला तसं मी Z6 सांगितलं होता, आपण हा फील्ड नाही येते. ओके, काय आम्ही जो सांगितलं होता तो Z6 होता. ते म्हणाले की नॉन झिरो एलिमेंट आहे ऑर्डर 6 कुठे? ओके, 3 आहे, 2 आहे, 3 आहे. ओके, हा पी तुमचा प्राइम नाही आहे. ओके, फॉर एक्झाम्पल आता in Z5, what are the elements? 0, 1, 2, 3, 4, and only. What is the order of 0 is 1. And each non-zero element has an order
1.
5. This one is 5. 2 5 are 10, 10 5 smaller 5. Okay, this one is 5. or each non-zero element is what? This prime. Okay, fine. Okay, any doubt? हा प्रत्येक एलिमेंट कसा असतो तुमच्या algebra
No,
फाईव्ह ला
sir.
रिलेटिव्ह प्राईम असतो. ओके, जर रिलेटिव्ह प्राईम असेल ना तर तो डायरेक्ट हाच एलिमेंट आपण काय घ्यायचा ऑर्डर करून घ्यायचो. ओके, फॉर एक्झाम्पल 37 0 1 2 3 4 5 6 आजचा आणि 1 आणि 7 चा काय रिलेटिव्ह प्राईम आहे. हे दोन सुद्धा रिलेटिव्ह प्राईम. ऑर्डर ऑफ 1 इज डायरेक्टली 7 1 7 7 7. ओके, each non-zero element okay has an order p, and zero element is the only element which has an order 1. Okay, any doubt of this? Okay, now in this
No,
case
sir.
each
No, sir.
non-zero element of f is of order p, and the zero element is the only element which has an order 1. Okay, now from the theory of group, from theory of groups, what we know, if A is an element of order p, and A raised to m is equal to e. Okay, in multiplication notation, or m into A is equal to e असेल. ओके, दोन दोन का लिहिलंय? हा तुमचा मल्टिप्लिकेशन नोटेशन. ओके, हा एडिशन नोटेशन. Okay, from the theory of group, if A is an any element of order p, and A raised to m is equal to e, or m into A is equal to e, this implies P is divisor of m. Is it correct? Okay, for example,
Yes, sir.
0, 1, 2, 3, 4. Okay, what is the order of 0 is 1. What is the order of this one? 1, 5, 5, 5, 5. Okay. Here, P is the order of each element. Okay. Now, 2 raised to 10. Okay, 10 into 2. What is the meaning of 10 into 2? 2 plus up to how many times? 10 times. Which is equal to 20.
10
But
times.
inside 5,
10
20 is equal to 0. Okay, so here 10 into 2 is equal to 0. So this implies this P is the divisor of 10. Okay, any doubt now?
10. No, sir.
This implies P is the divisor of M. Okay. Here P is equal to what? 0. Okay. Identity of additive group. Okay, so from the polynomial, what we have? A1, A2 is equal to 0. A1 is equal to 0. 2, A2 is equal to 0. 3, A3 is equal to 0. I into AI is equal to 0. Okay. So now we have I into AI is equal to what? 0. Okay, so this implies. But what is the characteristic of the field in the second case? P. So this implies P should be divisor of I. Okay, so this implies I is equal to lambda into p, where where lambda is some positive integer. Okay, any doubt? P is the divisor of an R.
No,
So
sir.
therefore, in this case, the term, in which term? X raised to I. Okay, in the polynomial f of x will be occur in the form x raised to I sin I is equal to lambda p, which is equal to x raised to p bracket raised to lambda. Okay, so this implies the polynomial f of x is equal to what? G of x raised to p. Okay, म्हणजे प्रत्येक टर्म कशी येईल म्हणजे x raised to I ची टर्म x raised to p lambda. Okay, that is f of x is equal to g of x raised to p. Okay, any doubt?
No,
No,
sir.
sir.
Okay. Wow. This one is x raised to 1. Okay, हा कसा येईल x raised to 1 x raised to lambda p च्या फॉर्म मध्ये x square कसा येईल x raised to lambda p. Okay, any doubt up to here? Okay,
No, sir.
so moving towards the next theorem, for any f of x and g of x belongs to capital F of x, right? So next one, for any f of x and g of x. Okay, f of x and g of x are the two polynomials belongs to capital F of x, and any alpha belongs to capital F in constant. Okay, arbitrary constant. We have f of x plus g of x bracketed is equal to f dash of x plus g dash of x. Second one, alpha into f of x bracket dash is equal to, okay, derivative of this polynomial is equal to alpha into f dash of x. Okay, easy to answer. Third one, f of x into g of x. Okay, derivative of this polynomial is equal to f dash of x into g dash of x. ओके, कोणतेही दोन पॉलिनॉमियल असतील तर त्यांचं डेरिव्हेटिव्ह काय होते? ते पाहिलेलं आहे, त्यात काय प्रूव्ह करायचं. ओके, लुक ॲट द सॉल्युशन. एनी डाऊट इन दिस स्टेटमेंट? कोणता पार्ट आहे समजलं नाही आहे सर? केस 1, to prove that f of x plus g of x is equal to f dash of x g dash x. Okay, plus g dash x. Now let's assume the two polynomial. F of x is equal to a naught plus a1x plus a2x square plus up to so on a n x raised to n, and g of x is equal to b naught plus b1x plus b2x square up to so on bm x raised to m. Okay, and suppose this n is greater than m. Okay, किंवा m greater than n असंही घेऊ शकतो, त्याच्यामुळे इतकं काही फरक नाही पडणार. Okay, suppose n is greater than m. Now consider f of x plus g of x, which is equal to, what is f of x plus g of x? A naught plus b naught plus a1 plus b1 x plus a2 plus b2 x squared plus up to so on. Now here n is greater than m. So this means am plus bm x raised to m plus a m plus 1 x raised to m plus 1. Okay, up to so on a n x raised to m. Any doubt? Okay, so a m plus 1 plus
No,
0
sir. No,
असेही
sir.
तो कोएफिशिएंट ऑफ याच्या पुढचे कोएफिशिएंट तुम्ही 0 ही घेऊ शकता up to m. So by the definition of derivative of a polynomial, written by the definition of derivative of a polynomial, this one, f of x plus g of x bracket dash is equal to, what we have, a1 plus b1 plus a2 plus b2 into 2x. Is it correct? Up to so on. M into am
Yes, sir.
plus bm x is to then minus 1. Okay, plus up to so on. This one is n into an x is to n minus 1. Okay, so this implies f of x plus g of x bracket dash is equal to, taking the coefficients of a1, a2 up to n in one bracket. This was a1 plus 2 a2 x plus up to so on m am x to m minus 1. Okay, plus up to so on n into an x to n minus 1. Okay, plus b1 2b2 x plus up to so on m into bm into x raised to m minus 1. Okay, any doubts? Which is the dash of x
No,
plus
sir. No, sir.
dash of x. Okay, so this one is f of x plus g of x bracket dash is equal to f dash of x plus g dash of x. Now, step number 2. Case number 2. To prove that alpha into f of x bracket dash is equal to alpha into f dash of x. Now consider first f of x is equal to f of x a naught plus a1 x plus a2 x squared plus up to so on a n x raised to n. What is alpha into f of x? Alpha into a naught plus alpha into a1x plus alpha into a2 into x squared plus up to so on alpha into a n into x raised to n. Now take the derivative of this one. This following by the definition of derivative of a polynomial. This one is this derivative of this one is 0 constant. this is alpha into a1 plus 2 into alpha into a2 x plus up to so on n into alpha into an into x raised to n minus 1. So this is alpha into f of x bracket derivative is equal to alpha to a1 plus 2 into x plus up to so on then an x raised to n minus 1, which is equal to alpha into the flash of x. Okay, any doubt? Case number third.
No, sir.
No, sir.
Since the product of f of x and g of x, product of f of x and g of x is a linear combination. Linear combination over f, capital F, of powers of x. Okay, yes. By virtue of previous two cases. By virtue of previous two cases, 1 and 2. Okay, it is sufficient to prove the result 3 for the product of two powers of x of two powers of x. Okay, let f of x is equal to x raised to r, and this is g of x is equal to x raised to yes, where r and s are what? Positive integers. Okay, r and s are positive integers. So what we have, f of x into g of x is equal to what? X raised to r into x raised to x. Is x raised to r plus yes. So now f of x into g of x, the derivative of this polynomial is equal to r plus s into x raised to r plus s minus 1, which is equal to r into x raised to r plus s minus 1 plus s into x raised to r plus s minus 1. Okay, so this is equal to r into x raised to r minus 1, okay, into x raised to s. Is it correct? Yes into x raised to
Yes, sir.
s minus 1 into x raised to r. This implies the dash of x into g of x plus f of x into g dash of x. This implies the derivative of f of x into g of x bracket derivative bracket dash is equal to f dash of x into g of x plus f of x into g dash of x. Okay, the previous case number 1 and 2. Okay, there is no need to prove again f into g, the product of take the product of f into g. Okay, तो खूप मोठा हो जाईल polynomial. It is sufficient to show that for the these two polynomial x raised to r and x raised to s. Okay, any doubt? परत काय असं का केलं? Okay, addition तर result होते. Okay, कॉन्स्टंट आणि
Yes,
स्केलर
sir.
Yes, sir.
म्हणलं प्रोडक्ट पण काय होतोय, प्रिझर्व होतं. ओके, सो show for these two polynomials only. Okay, there is no need to again prove all the product of two polynomials. If f of x is equal to yes, prove this theorem for these two polynomials. So here the f of x is equal into g of x bracket derivative is equal to f dash of x into g of x plus f of x into g dash of x. Okay, any doubts?
No, sir.
Okay. Okay. So some examples solve करा. Example wait a minute. Solve this equal homework. Homework. First one, f of x is equal to x cube minus 3. Okay. Find the splitting of splitting field of this polynomial over the field of rational number. Okay. Second one, f of x is equal to x raised to 4 plus 4 over the field of real number. Okay. Third one, f of x is equal to x square plus 3 over the field of rational number. Okay. Any doubt up here? Okay.
No, sir.
So
No, sir.
for today, it is sufficient now. Okay. And the next point is condition for the multiple roots. Okay. So what is the condition for the multiple root? We will see the next lecture. Okay. For this theorem statement वगैरह the theorem for next lecture लगेगा. Okay. Right done. What is the theorem says? A condition for multiple roots. Okay. Yeah. The polynomial f of x belongs to capital F of x. Small f of x belongs to capital F of x. Has a multiple root. Has a multiple root if and only if f of x and f dash of x has have a non-trivial that is of positive degree. In the bracket. Have a non-trivial common factor. Okay, if f of x and of course this is the polynomial f of x belongs to capital F of x has a multiple root if and only f of x and f dash of x have a non-trivial common factor. Okay, the proof of this theorem we will see in the next lecture. Okay. For example, look at here. Suppose f of x is equal to x minus 2 bracket square. Okay, what is the root of this polynomial? Plus 2. Okay.
Plus 2, plus 2.
What is the order of that root? How many times? 2 times. Okay, 2 and 2. These are the two roots. That means this
2
is the
times.
multiple root of f of x. Now, what is the f dash of x? 2 into x minus 2. 2 minus 1 is
2 into
4.
x minus 2.
Okay, now look at it. This is the f of x, this is the f dash of x, and this f of x and f dash of x have a common factor what? X minus 2. ओके हे
X
कधी
minus
येईल जेव्हा त्या पॉलिनॉमियलला मल्टिपल रूट असेल तर हा 2 नसेल तर काय होईल काय झाला असता हा जर 2 नसला असता तर f dash of x काय झाला असता 0 1
0
त्यामध्ये कॉमन
1.
फॅक्टर आहे का
1
कोणता असा आहे पहिल्यांदा कॉमन फॅक्टर आहे पण हा
no
काय
No,
नॉन
sir.
ट्रिवियल आहे का ट्रिवियल आहे पॉझिटिव्ह डिग्री आहे का आहे नाही ओके so the proof of this
no sir
next for today it is sufficient any doubt up here
No, sir.
okay so thank you for the attending this lecture okay you can leave now thank you